Hi guys, welcome to Unit 7. So Lesson 2, Volume of Prisms. This whole unit is about volume, and in my opinion, volume is such a breath of fresh air compared to surface area. So it's like we got surface area out of the way, yay, now we can focus on volume, which in my opinion is much more straightforward. Okay, so hopefully you will feel the same. All right, so let's get into it. First off, volume, or sometimes called capacity, those words are fairly interchangeable, is the amount of space inside an object or how much something can hold, okay? So that's what you need to think about when you think about volume. Even when you talk about your own volume, right? If you're, or like, sometimes I'll say, I'm like, oh, I am at capacity. It's like, that's all I can handle, that's all I can hold, right? So that's kind of like an emotional perspective, but also, volume could be like, if you were to fill a container full of marbles, right? How much space would that take up? So we've talked about one-dimensional attributes. That's like perimeter, right? That's just a distance. That's one-dimensional. Two-dimensional would be area, that right? How much does a flat surface take up? Volume is three-dimensional, all right? So the volume for prisms, is going to be the area of the base, so whatever the base is, whatever that area is, multiplied by the height. All right, so think about here, we've got our base, right? That's that like bottom layer, and then we're multiplying it. It's like, let's pretend like we stacked a whole bunch of those bases right on top of each other. How much would that be? All right, that's what that's talking about. So for a rectangular prism, right, that would be volume is equal to length times width. Well, that's the area, right? We've talked a lot about that. And then times the height. That's it. You're just multiplying three numbers together. Okay? A cube's volume, really, it's the exact same thing, but it's, they're all the same length, right? So you could say it's like the side length times the side length times the side length, which is really like length times width times height. They just happen to be the same distance, which is also equal to the side length cubed. Okay, right? This would be s to the third power, or three s's multiplied together. Okay, so we're going to do examples of both, so don't stress if you're like, I don't know what you're talking about yet. No worries. The first example I'm going to do is number 3 on your practice. It says, what is the volume of a cube with an edge length of 2.5 feet? Round your answer to the nearest thousandth. Okay, so when you get to problems like this, the best thing to do, draw a picture, right? Sometimes they'll give you a picture, sometimes they won't. But what this is saying is like we have a cube. So think about like a perfectly square box. That's what a cube is, or like a die from a board game. Okay, so let me draw that. And it says that it has an edge length of 2.5 feet. So what that tells me is that the length is 2.5 feet, the width is 2.5 feet, and the height is also 2.5 feet. Okay, so for the volume of this, if we have the side length cubed, right, or length times width times height, what we're saying is we have 2.5 cubed, or 2.5 times 2.5, oops, I didn't do a good job on that one, times 2.5, okay? So then you have to pay attention to what it's asking you to round to. Let me get my calculator up and then we can look at it together. You could do this multiple ways. You could use the cube key if you're using a scientific calculator, or you could also just do 2.5 times 2.5, okay, times 2.5, which gives us, let's see, where am I writing? I covered my book, which gives us 15.625. We were talking about feet, so this would be feet cubed. That is our final volume. Now it said round to the nearest thousandth. Well, here's my tenths, hundredths, thousandths. It's already in thousandths, so that amount right there is my final answer. Okay? So in this case, 3 numbers multiplied together. Man, it is allergy season and my nose is itchy. Number 2, which is also number 4 on your practice. What is the height of a right rectangular prism with a length of 2 centimeters, a width of 10 centimeters, and a volume of 75 centimeters cubed? Round your answer to the nearest hundredth. Okay, so with this one, let's see here. We were given, let's see, if it has a length of 2, that's just like a little guy. That's like maybe like that. That's 2 centimeters. And then it said a width of 10. So that's like really long. Right? And then we don't know the height, so this might not look accurate with what I'm drawing, and what the actual answer is, but this kind of gives us an idea. So maybe this could be like, I don't know, right now the way I drew it almost looks like a little, like a cereal box or something, right? Okay, so it's going to look something like that, ish. But with the volume for rectangular prisms is equal to length times width times height. But they gave us the volume. So I'm going to plug that in here, 75. The length was 2. The width was 10. We are looking for the height. Okay? And then it says round to the nearest hundredth. So we got to keep that in mind. Well, I can go ahead and complete this. I know what 2 times 10 is. That's 20. So now I have 75 equals 20 times h. Divide both sides by 20. Off the top of my head, I don't know what 75 divided by 20 is. So there we go, 3.75. So 3.75 is equal to the height. And we were talking about centimeters in this case. So my drawing wasn't completely accurate, but that's okay. All right, so that would be the height. So volume is length times width times height, right? I should be able to get back to 75 by doing 2 times 10 times 3.75. Number 3 is also number 3 on your quick check. Excuse me. A delivery truck service needs to transport 75 boxes. The boxes are all cubes with side length of 18 inches. How much space will the service need to transport the boxes? Okay, so there's a few different steps on here. First, we need to figure out, well, what is the volume, right? Because it's talking about how much space, right? So we're talking volume. Or you could also say, like, what is the capacity of the truck that they need? Now, so first, we got to figure out, well, what is the volume of one box? And then multiply that by 75, because there's 75 of them. So for the volume of a cube, that's the side length cubed. So in this case, that would be 18 cubed. Okay. So let's see here. I definitely don't know what that is. 18 times 18 times 18. 5,832 inches. Wow, that's a lot, right? So a side length of 18 inches. So think like 18 inches, that's almost like the length of your laptop maybe, right? So a box where it's a perfect cube, all 18 inches on each side. So we're going to take this amount, 5,832, and we're going to multiply that by 75, and that is going to give us the total volume that the truck needs to be. It's a big number. It is 437,400, and then usually in cases like this, you would say cubic inches. Okay, cubic inches is how you would most likely say that. All right. I hope this helps, and as always, reach out if you need more support. Have a great